What are we looking at here? The 13.6, the odds and ends, the little things that I didn't talk about that I needed to talk about. All right, so let's look at 2. If the sine of A is -8/10 and the tangent of A is -6/8, find the cosine of A given that angle A lies in quadrant 3. Well, that's nice and simple. You just draw in quadrant 3. Hopefully you know your quadrants. I know some kids don't. But anyways, that's quadrant 3. So we're going to draw in quadrant 3. We'll use A prime, it's a reference. And the sine ratio would be opposite over hypotenuse. So opposite of A prime is a -8. And this one needs to be fixed. That should be -8/6. I need to fix that. And the hypotenuse is 10. The tangent ratio is opposite over adjacent. So that's why I fixed it. -8 adjacent. And that needs to be positive too. Adjacent is a -6 because of direction. Now, you're asked to find cosine. Do remember, all schools torture children. Only tangent's going to be positive. So if you make your sign mistakes here, you can go back to this and say cosine should be negative. Your answer should be negative. But anyways, I'm finding the cosine ratio. I'm going to use the reference angle A prime. Cosine is -6/10, which reduces down to -3/5. That was a variation of a 3, 4, 5 triangle. All right, number 4 will be the next one I do. Cosine of y is -√3/2. What is the sine of A and tangent of A if A is bigger, if the tangent of A is greater than 0? This is saying that tangent is positive. This right here is cosine is negative. So I'm going to do my little ASTC here. And cosine is going to be negative here and here. Tangent is going to be positive here and here. The guy I double circled is where I'm going to draw. This is in quadrant 3. And we'll call this y prime. Cosine is adjacent over hypotenuse, so -√3 and a 2. By now I've taught how to do this by hand. You can press buttons in a calculator, you can, but I have taught how to do this by hand. You should recognize this is a variation of a 30-60-90 is what it is. The pattern I taught both Wednesday and Thursday looks something like this. A 60-degree angle opposite of a root of 3 and a 30-degree angle opposite of 1. And you see you've got a root 3 and a 2. Signs don't really matter much. That means this little length right here has to be a 1. Now direction does matter. It's falling. It is falling. So you need that. So the sine of A, I don't know why those are A's and are supposed to be Y's, but the sine of y prime here, which is going to be the same as the sine of y, would be -1/2, opposite over hypotenuse. The tangent of y prime would be opposite over adjacent, -1 over -√3. Cancel, cancel to make positive. Multiply by √3/√3, and she'd be √3/3, and she is positive. I'm not going to do 6, nor am I going to do 7. If you don't know how to do that, you find me and ask me. I'm not going to go over any of the drawing. You just need to know your little formulas here. I don't want to do 11 because you need to figure that one out. If not, you can ask. Let's see here. Evaluate the following trig ratios by drawing triangles or unit circles. So here's cosecant of 8 pi over 3. Now 8 pi over 3, you're going to have to probably convert to a degree. You're going to multiply it by 180 over pi. And what are you going to get here? You should get 480 degrees. So if I draw that angle, it's going to rotate once, take away my 360, and I'm going to have 120 degrees left, which would put me about right there. That's the angle. The last bit of rotation was 120, which means there's a 60-degree reference angle. All right? And that's what I'm going to triangle out. Again, here's your pattern. This is what enables you to do it. You got your 30, you got your 60, and a 30, 60, 90 is as easy as 1, 2, root 3. So opposite of a 60 is going to be a root 3. Direction matters. That one is going uphill. The hypotenuses are always positive. This one, which would be opposite of a 30-degree angle in a corner, is running left. And you want the cosecant ratio. Now, by the way, do remember ASTC. Cosecant is the reciprocal of sine, going to be positive. And it's a hoe. So hypotenuse over opposite. So the cosecant of 8 pi over 3 is equal to 2 over root 3, which you clean up by multiplying top bottom by root 3 over root 3, and you get 2 root 3 over 3. I'll do one of the coterminal ones here, which is 16. The cosine of twice pi. 2 pi would be 360 degrees. You're supposed to know that. So if you start here and rotate here, you end up right back where you start. You're supposed to do these with a unit circular approach, where your radius is 1. Remember, you're right here. The ordered pair here is 1, 0. From a circular approach, cosine of an angle is x over r, but since you're on a unit circle, it's x over 1. And the x value here is 1. So the cosine of 2 pi is 1. What she is. Let's do 20. Arctangent, root 3 over 3, it says by drawing or unit circles. By drawing or unit circles. And you can push buttons in a calculator on a test. This is understanding trig right here. And it's everything on the interval from 0 to 2 pi. This ratio is positive. So ASTC is kicking in. Here, here. That's where I draw. Tangent ratio is opposite over adjacent. So let's do in quadrant 1 where everything is positive. Opposite's a root 3, adjacent is a 3. When you get down here, the root 3 is negative because she's falling, and the adjacent is negative because she's running left. Now this is a variation of a 30, 60, 90. I swear it is. To go from a short leg to a long leg, you'd multiply by root 3. And you know, if you do negative root 3 times root 3, you get negative 3. This is actually the short leg. The reference angle is actually 30 degrees in both these triangles. I swear she is. And that's what I needed. One of these answers is 30 degrees. So 30 degrees is an answer. To get here, I rotate 180 and 30 more, I get 210 degrees. And express your answer in radians. 30 degrees would be pi over 6. You memorize that one. 210, again, you multiply by pi over 180, blah, blah, blah. You get 7 pi over 6. All right, let's do a solving one here, number 22. I'm going to divide the 2 out. All the things between 0 pi and 2 pi. So the sine of theta is root 2 over 2. To free up theta, you take the arc sine of both sides. And you basically get the problem set from above. Figure out what the arc sine of root 2 over 2 is. That ratio is positive. So I do a little ASTC, all schools torture children. I'm here, I'm there. Sine ratio has always been opposite over hypotenuse. So root 2, 2, root 2, 2. Now, if you take a root of 2 and multiply by a root of 2, you get 2. This is a 45, 45, 90 pattern. That's what she is. Swear it. 45, 45. You got everything you need. One of your angles is 45 degrees, which is pi over 4 is a pi rad. The other one would be 180 minus 45, which is 135 degrees. which again you memorized as 3 pi over 4. I'm going to save the inverse for you, and I'm going to save this for you. So, this is a review sheet. You should know how to do this. You should, shouldn't you? Hope you do.